Here's a screenshot from the previous video, and we're going to use this screenshot to redraw these two molecules. And so we start with the molecule on the left, and so there's a carbon here, and the carbon is bonded to a hydrogen, and the hydrogen is going straight up, and that bond is in the plane of the page. So we draw our carbon, and we draw the hydrogen going straight up, and we show that this bond is in the plane of the page. I decided to use chlorine as being yellow, and so therefore this bond is also in the plane of the page. So I go ahead and draw on my chlorine like that. I made bromine red, and this bromine's coming out at us in space, so we use a wedge to show the bromine coming out at us. I decided to make fluorine green, and this fluorine's going away from us in space, and so we can show that with a dash, so the fluorine's going away. This molecule on the right, we already saw in the previous video, this molecule on the right is the mirror image to the one on the left, but you can't superimpose the molecule on the right with the one on the left, therefore it's a different molecule. So let's go ahead and draw it. Once again, it has a carbon in the center bonded to a hydrogen that's going up, so I can draw that in there. It's also bonded to a chlorine with the bond in the plane of the page. This time the chlorine is going to the left. The bromine is still coming out at us in space, so I draw in the bromine. And then finally, this fluorine is going away from us, so I can go ahead and draw in the fluorine going away from us in space. Let's use these images here to talk about three definitions. So let me just move down here and let's look at these three different definitions. And we'll start with stereoisomers. So stereoisomers are isomers that differ in the three-dimensional arrangement of atoms. And so let's think about what the word isomer means again. So isomer means same parts. And so these two different molecules are composed of the same parts. Each of these molecules contains one carbon, one hydrogen, one fluorine, one bromine, and one chlorine. And in terms of what kind of isomer are they, well, we've talked about structural isomers before, or structural or constitutional isomers, but we can't classify these as being structural isomers. So let me go ahead and draw one more dot structure. This time I'm going to leave out the stereochemistry. So I'm just going to show a carbon bonded to a hydrogen, bonded to a fluorine, bonded to a bromine, bonded to a chlorine. So I've left out the stereochemistry. And you could see that this dot structure I just drew could represent either of these two dot structures that has the stereochemistry shown. And so they're all connected in the same way. They all have a carbon directly bonded to a hydrogen, a fluorine, a bromine, and a chlorine. So you can't say that these two isomers are structural isomers of each other. You have to say they are stereoisomers. They differ in the three-dimensional arrangement of atoms around that central carbon. So these are stereoisomers. Our next definition is enantiomers. So enantiomers are stereoisomers that are non-superimposable mirror images. And so once again, we saw in the previous video that this molecule on the right is the mirror image to the one on the left. But when we tried to superimpose the one on the right on the one on the left, we couldn't do so. So they're different molecules. And they are enantiomers of each other, which is Greek for opposite. Finally, our last definition here is a chiral center or a chirality center or a stereogenic center, or whatever term you'd want to use there. It has a tetrahedral, it's a tetrahedral carbon, so I think it's sp3 hybridized. All right, so if I look at this carbon here, in this dot structure, this is a tetrahedral arrangement of atoms, tetrahedral geometry. It has four different groups attached to that carbon. In this case, four different atoms. So a hydrogen, a fluorine, a bromine, a chlorine. And anytime you have this tetrahedral carbon that has four different groups attached to it, you create a chiral center. So this carbon right here is a chiral center or a chirality center. And so if you're starting without stereochemistry, if you start with this dot structure right here and you identify that you have one chiral center present in this dot structure, we've just seen one chiral center means two possible stereoisomers. So we have two possible stereoisomers. And we could write out a little formula here. So 2 to the n, where n is the number of chiral centers. Let me go ahead and write this. This is the number of chiral centers or chirality centers. So 2 to whatever power that is. In this case, for this dot structure, we had one chiral center. So we're going to say 2 to the first power. And this is equal to 2, of course. And this number tells us how many stereoisomers we have. And so we've already talked about that. So one chiral center gives us two stereoisomers. And these two stereoisomers that we drew are non-superimposable mirror images, right? So these are non-superimposable mirror images, so these two stereoisomers. And so they're a special type of stereoisomer that we call enantiomers. And we'll talk much more about number of stereoisomers in a later video. And in the next video, we're going to go in more detail about chiral centers and chirality centers and how to identify the number of chiral centers in a molecule.